The overall goal of this demonstration is to show a protocol for the production of protein-based nanoparticles that change hydrophobic surfaces to hydrophilic.
This demonstration shows how protein-based nanoparticles for hydrophilic coating are produced and how well they perform on the surface of target materials. The main advantage of this technique is that the coating is done in less than a minute. Demonstration will be done by my technician Jason Adkins, who has been working in the USDA laboratory for the past 16 years.
To begin this procedure, measure 150 milliliters of acetone with a graduated cylinder and transfer it to a 250 milliliter Erlenmeyer flask. While stirring, add 30 grams of commercial gliadin powder to the flask containing the acetone. Seal the opening of the flask with aluminum foil and continue to stir the solution at room temperature overnight. On the next day, filter the solution through filter paper. Then, wash the retentate with approximately 50 milliliters of fresh acetone. Following filtration, transfer the retentate and the filter paper to a square cell culture dish. Cover the dish with a piece of large filter paper to slow down the evaporation of residual acetone. After allowing the defatted gliadin to dry overnight, transfer it to an airtight container and store on the lab bench.